Okay, so let's get started. We're going to be taking a look at setting up and working with pulse width modulated outputs in control with our Link G5 and G4X systems. Now, a pulse width modulated output is going to be different than our on-off outputs that we discussed in our last training module. A pulse width modulated output is going to pulse a device to be able to control it in a certain fashion. Now, depending on what type of device we're controlling, so if we're dealing with an idle control motor or a boost control solenoid or even a cooling fan, we'll be pulse width modulating the actual device, a cooling fan, idle control solenoid, boost control solenoid, to get a different result. But the idea behind what we're doing is we're controlling the flow of current or the flow of airflow through that device, and that's going to get the result that we'd like. It'll make a little bit more sense as we go through some of these examples as we discuss this. We will be taking a look at idle control, boost control. Those are the very basic things that we're probably going to find ourselves interacting with for pulse width modulated control relatively frequently. And then we'll talk about jumping into doing some customized programming with pulse width modulated control to control a device like a cooling fan. We're going to be learning how to integrate a solid state relay between our link and the cooling fan or an electric water pump in order to make sure we're not having that switching load placed on the link because it can damage the output. So let's jump in here and talk about our pulse width modulated control. So the very first example I want to take a look at is not going to be found in the output window over here. It's going to be taking a look at idle control. So the idle control, depending on what type of idle control motor we're dealing with, can either be a pulse width modulated or a stepper. An example of a pulse width modulated would be a Honda engine or a Nissan engine. They generally use a pulse width modulated type of idle control motor. If we're dealing with something like a Mitsubishi Evolution or a Toyota Supra, they're going to have a stepper motor and they function in a different manner and they're not pulse width modulated in terms of the control. We'll be discussing and breaking down the idle control and the specifics with the idle control motors in future training tutorials. But for right now, let's just jump into our file here and let's just set up an idle control solenoid that's based around a pulse width modulated type of format so we can just see what this looks like. We're going to move from our Spark window over here to idle. And then in idle, we can first find that the mode is set to off. Let's go in here and just turn this on and let's set this now to a closed loop. So we have our difference here between open and closed loop. Closed loop allows the link to take control over the output in the pulse width modulated sense and being able to vary how much pulse width modulated output we're sending based on how far we're off from the desired target in our idle control. The open loop is just going to just ride off of whatever we program for pulse width modulated output and duty cycle control to the device. So this is difference between the control routines. Let's just keep it simple right now. Let's actually select open loop just to do something basic. We'll just click yes here. And now we see we have another type that we need to select, actuator type. We go in here, we have a solenoid, which is a pulse width modulated solenoid, stepper, E-throttle, which is drive-by-wire, and a 3-wire solenoid. Let's assume that we're doing this, again, very basic. We're sticking with a pulse width modulated idle control solenoid that's found on a Honda engine. We'll be selecting solenoid as our option here and click OK. The next thing it's going to ask us, if we take a look, the output. We need to assign the auxiliary output that we've wired to the idle control solenoid. Now in this case, the idle control solenoid is going to have 2 wires. One wire will be a power wire going into the solenoid. The other wire is what we're going to pulse with the pulse width modulated output control. Now we're going to be pulsing it in a 0 to 100% duty cycle range. That's what we find up here in our base position table. We'll discuss that here in a second, but we'll be having to understand which output is assigned from our link to control the idle control solenoid. Now let's just go here and select aux4. Let's assume just hypothetically that's what I've wired my link to control the idle control solenoid. So I have a 1 wire from the link going out to the idle control solenoid, the other wire on the idle control solenoids getting a 12-volt power reference. That's how all pulse width modulated solenoids will be set up. 2 wires, no polarity, but 1 wire is 12 volt typically. The other wire will be a ground that we're pulsing. You could, theoretically, wire the idle control solenoid a little bit differently, and you could actually go in and ground the solenoid and then send a 12-volt pulse to the solenoid. But if we're speaking of OEM type of idle control solenoids, that's never how they're wired, or at least anything that I've ever ran into. They're always low side pulsed, and then they have a constant power supply. Let's go ahead and select aux 4. Then the next thing we have to do is go in here to the active state. This is going to assign whether we're low side pulsing or high side pulsing the solenoid. Again, as I just mentioned, when we're dealing with an OEM idle control solenoid, there will always be a 12 volt constant power to the solenoid. The other wire will be a pulse width modulated low side pulse, where we're ground pulsing the solenoid. Again, you could theoretically wire the solenoid so that it's getting a constant ground, and then you're sending a high side or 12 volt pulse. I'm going to go ahead and just make sure I'm selecting low here because that's how a Honda solenoid is typically wired in the OEM wiring harness. Now we have a frequency we need.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.